Pleasant day, everyone. Welcome once again to our discussion for today. So, we're still on our topic on differentiation rules, but today we are going to focus more on the chain rule. Now, in order for us to be able to understand what does it mean chain rule, I'll show you some basic concept on the composition of functions. Okay, so we have here for the composition of functions. So function compositions is applying one function to the result of another. Okay, so for example, if you have this stage here, we have two stages, and we have an input here, then going inside this stage, so let this stage be our f sub of something, so whatever is our input here, then we have the output. The output of this first stage will be the input to the second stage, and then we have the final output. So the result of f sub, the result of this stage is sent through the next stage, and this is written as g, then small circle f, then we have x, meaning this is the composite function of x of g and f. So which means that this notation is equivalent to g sub f of x. So for example, if you are given, say, f of x equal to 2x plus 3 and g sub x equal to x squared. So x here is just a placeholder. So to avoid confusion, let's just call it input. Okay? So we have f sub input equal to twice input plus 3. So we can read it as f sub input equal to 2 times the input plus 3. Okay? And then this one, we call it g sub input equal to input squared. Now, let's start with this one. So the notation is g small circle f, then x. So this is the composite function of x of the two functions, g sub x and f sub x. So this is written as g sub f of x. Then we apply f. First we apply f, then apply g to that result. So from this diagram below, we have, our input here is x, so twice the input plus 3, so input is x, so 2 times x plus 3, so that will be the output of this stage. Then this will be the input to the next stage, where the next stage has input squared. So when you input this one, you have the output 2x plus 3 squared. So in symbol we have, or in notation we have, the composite function of x of these two function, g and f, function of x equal to 2x plus 3. So this is input to this stage, then squared. Okay? So next, what if we reverse the order of f and g? So we have this notation, the composite function of x of this function of x and another function of x equal to f sub g sub x. So next we have to apply g. Okay, so this is our g. So our input is x, so input squared, so the output of this stage is x squared, and this will be the input now. So we have 2 times the input plus 3, so therefore our input is x squared, so 2 times x squared plus 3, so that will be the output now. So the notation is the composite function of x of these two functions f and g equal to 2x squared plus 3. Okay, so if you compare the two, they are not the same. So you have to take note on that. Okay, so that is what we call composite function. So now let's proceed to our example. So for example, if you are given, or before that, so let's summarize now what we have seen a while ago. So we have this symbol, the composite function of x is written as f sub g sub x. So take note that the condition here is that if a function g is differentiable at a number x and a, or a function f is differentiable at g sub x, then this symbol f, then small circle, then g, so it's a composite function of x, of these two functions f and g. Then this one, composite function is differentiable at x. Okay, and then this is given in this notation, that the derivative of the composite function of x is equal to f prime of g sub x multiplied by g prime of x. Okay, so that's the formula of the derivative of the composite function. So for example, if we are given, say, f of x equal to x cubed, and our other function g sub x equal to 2x plus 5. Okay, now to find the derivative of this, so we have this symbol. Following the symbol, we have f, small circle, then g. It's not fog class, it's just f. This notation, it means that composite function. Composite function, the derivative of the composite function of x is equal to, so we start with f, so it means that we're going to substitute this 2x plus 5 to our x here in our f of x. Okay, so that we have an expression f sub g sub x. So what does it mean? It means that we have to substitute this one here and then take the derivative of that. So what is the derivative of okay, so let us write it this way first. We have f, so composite function of x is equal to, so you substitute the value of g sub x here, so we have 2x plus 5 then raised to a power 3. So what does it mean, class? We just substitute, we just plug in, this is our input, no? This is our input to the next stage. Okay, so first stage we have this, we input this one, 2x plus 5, so the output would be this one. Then the next stage, it has input cube, so whatever is the input, you cube that one. So this is our input, you cube that one, and then now the result, when you take the derivative of that resulting function, so this is equivalent to, so from the formula we have f prime sub g sub x then multiplied g prime sub x. So what does it mean? So it means that you have the derivative of, what is the derivative of this? So the derivative of this is, no, you use the power formula, so we have to bring that down, so 3 times 2x plus 5, and then the exponent is n minus 1, so our n is 3, so minus 1, that is 2, then times, so the derivative of this, meaning this one, the derivative of this, So 2x plus, because this is our g sub x. So derivative of g sub x, this is our g sub x. So that is 2x, derivative of 2x. Okay, so derivative of 2x plus 5. Okay, with respect to x. Okay, that is what is meant by this. So equal to 3 times 2x plus 5 then squared. So derivative of this, derivative of 2x is 2 and derivative of 5 is 0. Okay, so this is our derivative of our composite function of x. So therefore, this is equivalent to 6 times 2x plus 5 raised to a power 2. Okay, so this is our answer. So this is the derivative of the composite function of x. Alright, so I hope you were able to follow the solution. If you have any question, then please don't hesitate to send your message in our group chat. Okay, so take note, class, that we have this. What if, for example, no, what if I want you to practice this one? If you're asked, no, you're given. So this is our example number 2, but I want you to solve it by yourselves, no, just to test if you really understood what we are discussing now. So we are given the same f sub x equal to x cubed, and then you are given also the another function equal to 2x plus 5, but now you are asked to find the this one, the composite function of x, but this time we have g first is written. Okay, so I want you to find out what is this. Then after that, try to solve your derivative of the composite function of x. Okay, so for your practice, you just follow the step here. So the hint is something like this, class. So in our first example, we substitute, no, whatever is the function of g sub x, we substitute it here. Okay, now in this case, what you're going to do, you have to reverse the process. Okay, so I hope you you will be able to solve this problem, class. All right, so that's our chain rule. We have another case for chain rule. Okay, so the other thing is something like this. This is still a chain rule, class. Now, if y is differentiable function of x, or sorry, if y is a differentiable function of u, so we have if y is a differentiable function of u, all right, and u is the differentiable function of x, and u is a differentiable function of x, then we have this relationship, class. We have the derivative of y with respect to x is just the product of the derivative of y with respect to u, then multiplied by the derivative of u with respect to x. Okay, so this is what we're going to use in our next example. For example, if you are given so number 1, if you're given, say, y equal to the square root of u, okay, and then you're given u equal to x to the power 5 plus 1. So what is our answer. Okay, so what we're going to do, we just follow this formula above. Okay, so we have to find our dy over du, or derivative of y with respect to u. Then we have to find our derivative of u with respect to x, and then after that you multiply the two. Okay, so what is the derivative of y? So the derivative of y with respect to u is equal to, so this is a radical, so we will apply the power rule. So you express this in terms of rational exponent. So this is equivalent to this part here, your y. So this is the same as y equal to u to the power 1/2, right? So now if you take the derivative of this, so you have 1/2 times u to the power n. Our n is 1/2, so 1/2, then minus 1 times du. Our du over du is equal to 1, so no need to write that 1. So this is equivalent to, so 1/2 times u to the power negative 1/2, or we can write it as equivalent to 1 over 2 times u to the power 1/2, positive 1/2. And this is also equivalent to 1 divided by 2 times the square root of u. Okay? Then what is our du over dx? Our du over dx. So our this is our u, so it means that this is equivalent to the derivative of x to the 5th power plus 1 with respect to x. So this is equivalent to, so derivative, you apply the sum and the sum rule and also the power rule. So this will be 5x, this is 5, so this will go down. Then x to the power 5 minus 1, so this is 4. Derivative of 1 is a constant, that is 0, so you have plus 0, no? Plus 0 or equal to 5x to the power 4. Okay, now multiplying using this formula, the derivative of y with respect to x is equal to derivative of y with respect to u times derivative of u with respect to x. Then substituting, so we have dy over du, or derivative of y with respect to u. So we have 1 over 2 times the square root of u. Okay, then times our du over dx, so that is 5x to the 4th power. So therefore, we have 1 over 2 times, since our u is equal to x to the 5th power plus 1. So substituting this one in our radical part of the denominator. So we have square root of x to the 5th power, then plus 1, then times 5x to the 4th power. Okay, then we have here the numerator, then multiplied by 1. So finally we have 1 times 5x to the 4th power, so 5x to the 4th power divided by 2 times the square root of x to the 5th power, then plus 1. Okay, so that's our final answer. So this is our derivative of y with respect to x, or that is our answer. Okay, So I hope you were able to follow the solution. So this is the end of our discussion about the differentiation rules. In our next session, we are going to review what are the common mistakes, no, in using the derivative of functions. Okay, so thank you very much and see you again in our next video. Bye for now. Stay safe and healthy, everyone. God bless. Bye bye.